Oh. So the first thing I want to do is talk to you about a concept that you should have learned already. It's called the greatest common factor. And we'll call it a GCF from now on. Okay? Put that up. This is important. All right. Tell me what a greatest common factor is. What's a GCF? Anybody? Somebody said greatest common factor, yes. Let's say I give you two numbers. Maybe I give you 24 and 18. And I said, what's the greatest common factor of those two numbers? What would you tell me? 6. Y'all said 6, right? You're absolutely right. Good job. Here's what we're doing. We're thinking about all the factors that multiply to give you 24. Okay? And let's start lowest to biggest. So what all goes into 24 evenly? 1. You're right, but let's list them all in order. 2, 3. Come on, y'all. 4, 6, 12, 8. Yep, I missed 8. And 24. Okay. How about the factors of 18? 1, 2, 3. Somebody said 3. 3 is a factor. No, 4 don't go in 18. 6. What else? 9. What else? 18. Of those listed numbers, which one is the biggest that they share? So the greatest common factor of these two is 6. Does that make sense to you? Okay. That is the foundation of factoring. Okay? You have to be able to find that GCF from any number. But we're going to throw some variables in there too, since this is algebra. Let's say I had 15x squared and 20x. What is the GCF there? 5 is part of it. Remember, think about what GCF means. It's a factor. It goes in evenly. So yes, 5. How about those variables? What happens there? I got one with 2 x's and one with 1. How many could you take out of both of them? Evenly. 1. So it's 5x. Okay. Well, that's how we find the GCF. Now we're going to divide it out. No, there's a lot to this. I'm trying to take like baby steps in time. What if? Think about this with me for a minute. If I asked you to expand this, what would you do? Starts with a D. Distribute, right? And so that 2 would multiply to everything. So I'd have, and then 14. What if I went backwards, though? Because that's what factoring is. Factoring is doing the backwards things. So what if instead of starting with the number on the outside, I started with this? Can you think of a GCF that I could take and put on the outside of that? So backwards distribute pretty much, even bigger. Even bigger. 6. Do you see that? Does everybody see that? Do we all agree that the GCF, okay, so look, What's the biggest thing you can divide 6, 18, and 12 by with no remainder? 6. I can put it on the outside. Now this time, instead of distributing, I'm doing the opposite. So I'm not multiplying. What am I doing? Dividing. What's left in that first term? 1 what? Plus, just 3x, plus, somebody said 2. Does that make sense?
Oh, so you gotta divide.
Instead of multiplying, we're dividing by the GCF. So we divide, and I'm going to put you a note here. We're doing the backwards of distributing.
How did you get?
Let's do another one. Somebody say wait. I'm sorry. Tell me when you're ready. When I go. This one's a little bit harder because the numbers are getting a little bigger. GCF. 25. 25 is the GCF here. So if I take a 25 out, yes, when you find a GCF. Not always by the first one. I'll show you one in a second that's not the first one. What's left? X squared minus 4x plus 75 divided by 25 is 3. Make sense? Let me add a variable in there. I'll just do a line here like this. This is another example. How about if I had 6x squared minus, actually, let me make that, let me make that 3x. Huh? We're rewriting it. Factored means things that multiply together to give you something. So right now, we're getting it in multiplied pieces. All right. What's the GCF of those two? Even bigger than 3.
6.
And when I say bigger, I don't mean number-wise. What else do they share? The number in front, the GCF of 6 and 3 is 3, but they also both have an x. So let's think about how we could take that x out. If the GCF is 3x, what's left? In other words, what do I need to go right here to make it look like this again? 2x, right? X times x is x squared minus, well, I'm taking a 3x out, so you're dividing it by, you're right, 1. So the question is, if I distribute this back through, do I end up with what I started with? What's 3x times 2x? Plus 3x times negative 1? Negative 3x. Okay? So if you take everything, you hold its place with a 1. All right, are y'all ready to actually factor now? All right, so when we factor, what we're going to do is we're going to take these quadratics, okay, just like we've been graphing, and we're going to factor them down. So we're going to take something that looks like this, and we're going to make it into something that looks like this, okay? Remember, it's the opposite of distributing. If you FOIL this out, if y'all think back to foiling first, outside, inside, yeah. I haven't got to the sheet I just gave you yet, no. I'm just showing you what we're going to be doing. So it makes sense. No, you don't have to write this down. just to show you that it's the same thing, you're used to taking it from here to here. You're just not used to taking it from here to here. Okay, so we're going to break it down into those pieces like that. So I've got you a step sheet. The key to being able to factor is being able to recognize a GCF, which is why it took so long to start with as we talked about a GCF, okay? All right, so there is an example on this sheet, okay, at the top that we're going to run through. You don't have to worry about writing this part because it's on this sheet, but pay attention and ask questions if you have them, okay? All right, so we're going to start with the directions. We'll just say, take this quadratic and factor, okay? Your first step to factoring is always taking out a GCF. That's the first thing you do every single time. So looking at this example, does it have a GCF?
Yes.
Yes, what is the GCF? 2. Do we all agree? Just like the ones we just did. So if we take that 2 out, like we did before, what's left? Y'all can do this. 6x squared, 7x, and 2. Okay? All right. Now here's what I want to do. I want you to list out A, B, and C. We're going to ignore that 2 in front for right now. We'll get back to it in a minute. But right now, tell me, what is A? How about B and C? All right. Take the first and the last, take the A and the C, and multiply them together. What do you get? 12. This is the puzzle part of factoring. I need 2 numbers that multiply to 12, but add to 7. Somebody said it. 3 and 4. Do we all see? If you struggle with that, list all the factors out of 12. There's lots of factors of 12. Come on, pen. All right. So, for instance, 1 and 12, 2 and 6, 3 and 4, and y'all said 3 and 4, and that's right, because 3 plus 4 is 7. It adds back up to the middle. So here's what we're going to do. We're going to rewrite 7. I'm going to keep that 2 out front. I'm going to keep the 6x squared. I'm going to keep the 2 on the end. But instead of putting 7x in the middle, I'm going to do plus 3x plus 4x. Is that the same thing? Sure. That's like saying 7 is the same thing as 3 plus 4, and it is. Now what I'm going to do is look at this as 2 separate problems. I call these slashing problems. Look at just the first 2 terms, just the 6x squared and the 3x. What is the GCF? 3 what? 3x. I'm going to take it out of the first 2. All right, the 2's still here. Don't worry about that right now. 2x. What's left? Oh, 3x. I'm sorry. No wonder y'all look at me like I'm crazy. 3x. What's left if you take a 3x out? What's left here if you divide by 3x? Somebody said it. 2x. I'm dividing 6 by 3. Right? Not the 2. Don't worry about this 2 in front. I'm talking about the GCF of just these 2 is 3x. So if I divide this by 3x, I get 2x. How about here? Nothing, which would be what? What do I hold the place with? 1. Okay. I told you it's a difficult concept, but we're going to spend some time on it. Bring the first sign down. Now look at just these 2. What is the GCF? 2. If you take a 2 out of those 2 terms, what's left? 2x plus 1. Okay? Now what happens? Do you notice that these 2 sets of parentheses are exactly the same? Okay?
No.
right? 2x plus 1. What I'm going to do now, and this is the last step in factoring, I'm going to take, you know how we've been taking an x out? Now I'm going to take out a 2x plus 1. And if those are gone from each one, what's left?
Squared.
3x plus 2. Now it is factored. Some of you are like fixing to stare a hole through the board, and other people are like, whatever. This takes practice. We're going to practice. Let's do another one. This is the first one on this side, so now you can start writing. No, what's that book? Yes, I would write under here, wherever you want to write. This is for your notebook. All right, so let's run through our steps for this one. This one's number 1 on your notes there. What is A? Well, it's the number in front, so it's 1. What about B? How about C? Okay. Multiply A and C together. What do you get? I need 2 factors of 5 that multiply to 5 but add to what? 6. 1 and 5.
And multiply to 5 and add to 6.
Yep. Now this one, and I didn't mention to start with it, I should have. We didn't take a GCF out in the beginning because this one didn't have a GCF. All right, so rewrite 6 using these 2 numbers. So now it's going to be x squared plus 1x plus 5x plus 5. Do you see what we did? This and this are the same thing. I just wrote them a different way. All right, let's slash it. First 2. What's the GCF?
1.
1x. What's left when you take an x out of those 2? Yep. X plus 1. We all see where that's coming from? Keep this middle sign. And how about a GCF of the second 2? 5. What's left? X. Do you see the same factor there? What is it? X plus 1. So I'm going to take an x plus 1 off of them. And then whatever's left, that's exactly right, the x plus 5. This is different than the way I did it before. You like it better or not? Cameron?
I like it.
It's a little more intuitive, I think. Let's do another one. Okay, minus sign in it. This is number 2. Does it have a GCF? Does it? I'm sorry. X plus 5, x plus 1. All right, does this next one have a GCF? I hear yes, and I hear 4, and I hear no. It's got to go into all 3 of them to have a GCF. Does it have one? Other than 1? No. So I'm good to move on to the next step. What is A? How about B? How about C? Yes? Multiply A and C together. What do you get? Negative 12. I need 2 numbers And here's where it gets tricky. It's got to multiply to negative 12, but add to negative 4. What's the only way you can get a negative number when you multiply? Somebody whispered it. One's negative and one's positive. So I could have 1 and 12 this way or that way. I could have 6 and 2 this way or that way. I could have 3 and 4 this way or this way. Do you see what I'm getting at here? To get a negative number when you multiply, you have to have one positive, one negative. So what multiplies to negative 12 but adds to negative 4? Negative 6 and positive 2. Do y'all see that? You got to watch your signs. Negative 6 plus 2 is negative 4. Negative 6 times 2 is negative 12. So again, I'm going to rewrite this as negative 6x and positive 2x. If you keep your negative number first every time, it'll make your life a lot easier. Let's slash it. How about the first two? What's the GCF there? 1 what? X. What's left? Minus 6. All I did was take an X out of both of them. How about the second two? 2. What's left? X minus, we're taking a 2 out. What's left? 6. If I've done it right, both of these parentheses are going to be exactly the same. And I can take those out and put them in the front. So I take out the x minus 6. And what's left? If those are gone, what's left? X plus 2. And it's factored. So making a little bit of sense?
Yeah.
Let's do the next one. Okay, I'm sorry. The next one's a little bit tricky. Let me look first. Do I have a GCF? 4. 4 goes in, right? I'm going to take that out. What's left when I take out a 4? Minus what? 36 divided by 4, 9. I am missing something here. Yes. You're missing a B. So that tells me that my B is going to be what? 0. A is 1. What is C? What's C? Negative 9. Multiply the A and the C together. Negative 9. So I need two things that multiply to negative 9, but when I add them, I get 0.
Negative 3 and positive.
Y'all got it. 3 and negative 3. 3 plus negative 3 is 0. 3 times negative 3 is negative 9. So I'm going to rewrite that middle as 3x minus 3x. And I intentionally put the negative second, even though I told you not to do that, because I want you to see what happens when you have a minus sign. Most of the time it's easier if you have one positive, one negative. If you do the negative first, like if I'd done negative 3x and positive 3x, it would be easier, but it's not, you don't have to. I'm going to show you what you do if you end up with a negative here. That's why I did it this way. All right, so we're ready to slash. We've got this 4 on the outside that we're just going to ignore. We're going to leave that alone out there until we're finished, and it'll just follow the problem down. GCF of x squared and 3x. 1x. If I take 1x out, what's left? Yes. Remember how I told you had to keep this middle sign? Well, now it's a negative, which means whatever I'm taking out, I have to change the last sign. So you might want to put yourself a note somewhere. When the middle sign is negative, change the last sign. So here, when I look for the GCF, what's the GCF of 3x and 9? 3. Because that middle sign is a negative, what's left in the first one? X. I'm going to change this sign to plus. And then it leaves me with the 3. So when that middle sign is negative, only when it's negative it changes that last sign. Because that negative would have to distribute through and change the sign.
Well, we don't have to have
Is that
it.
the final answer?
No, that's not the final answer. Why is that not the final answer? I got to take that x plus 3 out. And what's left when you take that out? Yep.
But
For that one, you didn't have to put the negative there, but there's going to be some that will have a negative in the middle no matter what you do. So you have to know, I've got to change that sign if it's a negative in the middle. One more before I give you something to practice on your own. Hopefully it's not looking like Greek anymore. Is it a little bit better? It is kind of confusing. It's a confusing concept. All right, let's look at the last one here. You tell me, what is my first step before I factor? Get the GCF out, that's right. If it has one. Hopefully, it won't have one, and most of them don't, but I gave you plenty of practice with ones that do. So what's the GCF here? 2. If it doesn't have one, just move on forward. All right, what's left? Yep. Y'all got to be more confident, y'all. 7x plus 6. What's A? B? And C. A and C together give me two things that multiply to positive 6 but add to negative 7. Oh. Now think about it. There's two ways to get a positive number. A positive times a positive and a negative times a negative. What are two factors that multiply to positive 6 but add to negative 7? Somebody said it. Negative 1, negative 6. Negative 1 times negative 6 is positive 6. Negative 1 plus negative 6 is negative 7. Does that make sense? I know y'all look at me like you've had enough. I'm almost done, I promise. Rewrite negative 7 as negative 1 and negative 6. It's still the same thing. I'm just writing it a different way. You do get it? Good. Slash it. First two terms, what's the GCF? 1x. What's left? X minus 1. Y'all are not very confident, and you're saying the right things. I wish y'all would be confident in your answers. All right, keep the middle sign, and since that middle sign's negative, I need to make sure I change this one when I factor. GCF of 6x and 6. 6. What's left? X minus 1. That's only when the middle's negative. All right? What goes in front? What now? Yep. What's left? Done. It's going to take practice. I promise it takes a lot of practice. Don't get frustrated with it. Hopefully